and girls. So for the next 2 weeks, we're going to be moving into lessons 23 and 24 in our RCC book. And these lessons are going to be about multiplying fractions, okay? Luckily, multiplying fractions is actually pretty easy, so I think you guys will be pretty good at this. All right, so today is Monday, and we are going to be doing pages 489 to 494 of the RCC book. But the first few pages are the family letter. So I put those kind of poster style. So we're going to go over that here. Okay. So I just want you to be paying attention to me going over this poster right now. Okay. This is really important, guys. So I want to make sure you're not just like looking and zoning out. Like you're really kind of thinking about what I'm talking about. Okay. So, our target or our goal is that we can multiply a fraction by a whole number. A whole number, guys, is just a plain old number. 6 is a whole number. 23 is a whole number. 75 is a whole number, okay? A whole number is not 72.1, or a whole number is not 1/2, okay? A whole number is just a single actual number. So, I just want you to keep in mind with this lesson, it's important that you know that you can put a whole number over 1 and it means the same thing. So 4 over 1 is the same thing as 4. It means 4 wholes. 6 over 1 is the same thing as 6. That means 6 wholes. So when we get into multiplying fractions a little bit deeper, you're going to need to be putting your whole numbers over 1. Okay, so I just want you to know that you can put any whole number over 1 and it doesn't change the value. Okay? So in this lesson, you're going to see some things like this. Right here is a visual of some fractions. What do each of these represent? So these are each divided into how many equal parts? 1, 2, 3. How many of the parts are shaded? 1, 2. So these each represent 2/3, right? So I'm showing you that you could either use repeated addition or multiplication. Here's the repeated addition. I added 2/3 plus 2/3 plus 2/3, right? That's exactly what my picture shows. Now, since I already have a common denominator here, I can add right across. 2 plus 2 is 4, plus another 2 is 6. That's going to give me 6 over 3, okay? The same thing can be represented by multiplication, guys. So I have 2/3 here, right? One of these is 2/3. How many times does it show up? 1, 2, 3. So I can also do 2/3 times 3. Now when I multiply by a fraction, I'm just multiplying the whole number by the numerator, okay? So I'm going to do 2 times 3, which is 6. My denominator stays the same. Don't change your denominator. It stays the same, okay? So, as you can see here, these both equal 6/3, right? Next one. Here I have another visual, okay? These are each divided into halves, right? This divided into 2 equal parts. How many of the parts are shaded? Just 1. So I showed repeated addition, 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. And we need to add these right across. So 1 plus 1 plus 1 plus 1 plus 1 is 5. And our denominator stays the same. Or you can show it as multiplication. So you have 1/2. How many times does that show up? 5 times, right? Hence the multiplication sign. 5 times 1/2. So you multiply the numerators only by the whole number. 1 times 5 is 5. And you keep the denominator the same. So that's going to be 2. So our repeated addition and our multiplication showed the same thing. 5/2. Now, you're going to also have to show this on a number line. So this number line here is split up by halves, okay? 1/2, 1. 3/2, 2. 5 halves, 3. Okay? Now, if I need to represent this on a number line, I have to jump up by 1/2 5 times. So I'm going to go 1/2. That's 1. 2, 3, 4, 5. My answer here is 5 halves, which is exactly what I got here and exactly what I got there. Okay, so that means I'm on the right track. Okay, so that's the introduction. Now I want you to open up to page 491, please, in your RCC. Okay, so we're on 491. Pause me if you need a minute. All right, so number 1 says, look at the model. Write an addition equation to add the 1/3, right? These are all showing 1/3. They're split into 3 equal parts. One of them is shaded. So now I need to do repeated addition for this. So how many times do I see this? 1, 2, 3, 4. So I need to add this 4 times. 1/3 plus 1/3 plus 1/3 plus 1/3. Okay? Now I add straight across. 1 plus 1 plus 1 plus 1 is 4. And it's going to be over my denominator, which is 3. So I can double check this and see if my visual represents the same thing. Does this show 4/3? Yeah, it does, right? 1, 2, 3, 4 are shaded. 4/3. Number 2. You can use multiplication with fractions to show repeated addition of fractions, just as you do with whole numbers. Complete the sentence and equation below. So, now I'm going to show this in multiplication, because this is repeated addition. Repeated addition just means you're adding over and over again, okay? So it says blank copies of 1/3. So how many times do we see 1/3 here? 1, 2, 3, 4. So 4 copies of 1/3 equals, so when I multiply a fraction by a whole number, I do the whole number times the numerator. 4 times 1 is 4, and my denominator stays the same, so it stays 3. Okay, just like I got up there. So that means 4 times 1/3 is 4/3. Okay? Pause me if you need to. Otherwise, I'm going to move on to page 492. So, here it says look at the model below. Okay? Right away, I notice I have thirds here because it's split into 3 equal parts, and 2 of them are shaded. So I know that one of these shows 2/3, right? Now it says write an addition equation to add the 2/3. How many times do you guys see 2/3? I hope you're all saying 4, right? So we're going to add 2/3 plus 2/3 plus 2/3 plus 2/3. Okay? Now, our denominators are all the same, so we can add the numerators right across. 2 plus 2 is 4. Plus another 2 is 6. Plus another 2 is 8. I could have done this, guys. 2, 4, 6, 8, right? 8 over, never change your denominator. Stays the same. 3. Okay? Now I'm going to show this as a multiplication problem. So blank times 2/3. How many times do I see the 2/3? I see it 4 times, right? 4 times 2/3. When I multiply by a whole number, I do the whole number times the numerator. 4 times 2 is 8. My denominator stays the same. Okay? 8/3, that's the same as we got up there. Next. Look at the model. Write an equation to add the 1/3. I know this is 1/3 because these are each split into 3 equal parts, only one is shaded. So I'm going to go ahead and count them to see how many times I need to add them. 1, 2, 3, 4, 5, 6, 7, 8. All right, I need to write this out 8 times. You guys are going to do it too. 1/3 plus 1/3 8 times. Whew. Okay, pause me if you need to catch up. Otherwise, I'm ready to add. My denominators are all the same. I need to add up my numerators. They're each 1, right? And I know that 1 is here 8 times, so I'm pretty smart when I use my brain. I'm just going to say, I know 1 8 times is 8, right? 8 over 3. My denominator does not change. Okay? So what's the multiplication sentence we're showing here? How many times do we see 1/3? We saw it 8 times. When we multiply, we do the whole number times the numerator. 8 times 1 is 8. My denominator stays the same. Okay. My number 5 is reflecting on this, all right? So I want you to realize that when we look at these two problems here, whoa, magnets are going crazy. We're getting the same answer, right? Oops. So, and that's because when we did the multiplication here, 4 times 2 is 8, and our denominator is 3. 8 times 1 is 8, and our denominator is 3. Okay? So you're going to start to see some problems that are looking for you to find a certain fraction. Okay? So I just wanted to point this out to you so that you'll know it when you see it. Okay? So even though these are 2 different multiplication sentences, they're representing the same amount of thirds. This is 8/3. This is 8/3. Okay? All right. Page 493. Only have 2 more pages, guys. Making good time. All right. Number 2, complete the statement and the equation for the fraction model. So, it's asking for how many copies of 1/4 are there? Well, let's see. 1, 2, 3, 4, 5. I see 1/4 5 times. So, I need to multiply that. 5 times 1 is 5. And my denominator is 4. Okay? The reason it stays the same, guys, is because I'm still working with fourths, right? This tells me 5 times 1/4 is 5/4. And right here I see there's 5/4 here. Okay? 5 times 1/4 is 5/4. All right? Pop over to page 494. Oh yeah, I forgot to tell you that. On page 493, I skipped the big chart thing, right? I always skip those in distance learning. It's too much jibber jabber. Okay? So now we're on number 3 on page 494. Okay? It's asking me, write an addition equation to add the 3/4. How many 3/4 do we have? 1, 2, 3. So we need to add that 3 times. 3/4 plus 3/4 plus 3/4. What does that equal? 3 plus 3 is 6. And then 6 plus 3, 6, 7, 8, 9. 9 over 4, right? I'm not changing my denominator. So this means, how many times did I multiply 3/4? 3 times. 3 times 3 is 9. And my denominator is 4. Okay? Last problem. a bunch of these this time. All right. Gonna give you a hint. The answer is going to be the same as the previous problem. We're just looking at it in a different way. So how many 1/4 are here? We need to make the addition sentence. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to cut you guys some slack and say we can just write this. Add 1/4 9 times. Okay? Because if we write out 1/4 9 times, that's kind of a lot. So for time's sake, we'll just write that. Now, let's do it as a multiplication equation. How many times does 1/4 show up? It shows up 9 times, right? There's 9 1/4 here. So we got 9 times 1/4. Let's multiply this. 9 times 1 is 9. My denominator stays the same. It's 4. Okay? So this is going to be the same as if I were to add 1/4 9 times, right? All right, guys, go ahead and take a look at what else you have to do for math today. Make sure you're earning those 2 green lights on reflex a week. If your reflex is glitchy, just make sure you're spending 10 to 15 minutes on it every day. That's going to help you guys out with your fluency a lot. Okay? Have a good afternoon.